Hello and welcome to Metro Home Theater Tech Tips. I'm Brent.
I'm Adam.
And welcome aboard. So, what do we got today, Adam?
Well, we've got kind of an interesting episode with us today. So today, this is a topic that, as an integrator, somebody who goes out and integrates home automation systems with their media and everything else.
Just make sure, an integrator that integrates.
Yes.
Okay.
Yes. This is something that I have to deal with on a daily basis, and even here during tech support, it's something that we get calls on fairly often. So,
yes, I noticed that there is a
university
remote right there,
there's a university remote,
an RTI behind us.
Yeah,
so there's still
RTI.
a whole lot of IR going on in the world.
So today's episode is on infrared. If we are to quote a certain person who tried to copyright that term, it's hot.
It is hot.
It's hot.
It's hot.
Anyways, all that to say, we're going to be talking today about how infrared works. We're going to get kind of into the nitty-gritty details. You'll see on that picture, I've already got kind of part of it drawn out here for us. I'm going to show you that and to give you an idea of where infrared light is on the light spectrum, or the EM spectrum, but also how that's broken down and how a signal is actually transmitted from a remote to the device. And so we're going to kind of dive into that. But more importantly, Brent, what is today's episode brought to you by?
Today's episode is brought to you by the letter I.
The letter I.
And why is that?
For CS-I IR Kit 1, IR Kit CCUS.
Yes, it is.
Yes, and what is that kit?
The IR Kit CCUS is our IR distribution block with a built-in double throw relay that allows you to control anything: blinds, curtains, lifts, our AIO, AIO2, that will work with a contact closure trigger. Most importantly, the IR Kit CCUS is a code learning device.
Right.
What this means is you can take any remote, pick two codes off of it. Our favorite around here is the Sony remote. We take a Sony remote, generally we use channel up and down because we're not using the built-in tuner here.
Right.
And that allows us to open A, close B, or open B, close A.
Yes.
So a tremendous amount of flexibility.
Yep.
And it is available already. Check with your salesperson and our distributor.
Yes, and find out pricing on that by going to them with that. So, all that to say, we'll go ahead and dive in, and I'm actually going... Oh.
But not yet. Don't forget, like us on Facebook.
Yes.
Subscribe on Facebook. We have a goal to get to 1,000, and we need to get there.
On YouTube is
on
what
YouTube,
we're trying to get.
yes.
Yeah, so we are at 840 something subscribers.
So
which,
we need 150
again,
more people, guys.
Thank
get to
you
work.
so much for subscribing to everybody who's subscribed. Like, share, give us a thumbs up. Hit that subscribe button. Hit the little bell to that way you get notified when we go live and when we upload new videos. Because we try to do that fairly often. And so definitely do that for us. And of course, like us on Facebook. Find us on Twitter and Instagram.
Check out the entire playlist. We got a whole lot of information out there on our YouTube channel.
Yep. So with that, we'll go ahead and dive right in. So what I'm going to do here is I'm going to switch over to the top-down view. And what you all are all going to see, if I can hit the right button, there we go. Okay. So what we have here, we have our EM radiation, or our EM spectrum, electromagnetic spectrum, right? So we have all the way from the low end, which is our radio waves and TV waves, all the way down there, and it moves all the way up here to our gamma radiation. Of course, we have Mr. Banner up here to tell us what the gamma radiation is. So.
Wait.
It's a pretty
what
well
about
drawn,
Superman?
Well, Superman's our X-rays.
Okay.
Yes, and so pretty well drawn, banner over here, I would say, anyways. I'm an artist, right?
Now, Banner would be in the white coat. That is, without question,
sorry, that is the
Hulk.
There we go. Okay. So now, what I really want to point out here, of course, is this is the visible light spectrum. And you'll notice that it's drawn out here. And that's because the visible light spectrum on this entire EM range here is actually a very small section of this range. And just to kind of give you an idea, the infrared light, so infrared light, of course, is heat, and that's how it radiates away from whatever device is hot. It does it in an infrared light fashion. And so this is actually a much wider gamut of frequency than what the visible light spectrum is.
Yes, in fact, as I recall, you wrote all this down. So the IR spectrum runs from only 300, well, I say only,
right.
from 300 to 400 terahertz.
So it's 300 gigahertz to 400 terahertz. So there's actually
which is a giant spectrum, whereas the visible light stays fully within the terahertz range from 405 to 790.
Right. So, and terahertz, correct, yes. So with that, there's also kind of an interesting thing because the IR remote only uses a very small portion of that frequency itself, because and actually it jumps a little bit into the radio wave section because it starts at 300 megahertz and goes up to 400 gigahertz. So when you are looking at the IR remote and how it works and everything else with it, you really kind of have to, kind of know where you are at. And the reason that we understand why this is important to know is because in the real world, you have to deal with certain items that are actually radiating infrared light, and they can cause interference with your IR remote.
Even visible light.
Yeah, exactly.
Because it's so bright.
Yes.
By being a higher frequency, it just walks over.
It'll either walk over it. You have the harmonics issue where it may be harmonizing at the perfect frequency in order to walk over that. You may also have an issue where you have a light that is just a hot light. You don't have that as often anymore with LED. However, you may have a light that's actually extra hot.
Particularly plasma.
Yep, plasma TV, and so that will actually radiate that information out and walk over top of your IR information. So keep that in mind when you're out in the field and you're trying to work with infrared light and it's not working right. One of the things that I use, and I don't know if I do. One of the things
Once
that I
again,
use,
this is our working lab.
Yes. We have these here. So this is actually one that I've chopped up and I've used portions of it, so it's not as pretty. So I'm not going to give you a close-up shot of it. But this piece here is great because what it is, it's an IR cover. And you can usually find them in different areas. Of course, ask your rep. The part number for this is the CS-IRE-CUS. But the nice thing about this piece here is that you actually use this to cover up your IR emitter, and it covers up the IR sensor of whatever device you're actually trying to control, and it blocks out anything other than that emitter that you're trying to use.
Particularly useful when you have a stack of the same items, satellite receivers, cable
Right.
boxes, Apple TVs, Roku's, things like that you're controlling with the IR.
Right.
Because an emitter can be fairly powerful, and if it's in a cabinet, it will reflect off the door and hit other items.
Exactly, yeah. And now in many situations we've run into out in the field where you are trying to control a certain device and you may have the device over here, but behind you, you have a window that's facing outside and maybe it's facing to the east or to the west. And so in the morning or at night, you've got the light from the sun coming directly in from that window. And during that time, your remote's just not working.
Swimming pools will also absolutely do that.
Yeah. Yeah,
they will
as
just
it
that
refracts
reflected
off
light
of it.
will overload your IR receiver
Exactly.
terribly.
Yeah, which you know that from personal experience.
Yes,
What
well,
you've had to deal with.
Yeah, and in the old days there was not RF, so we had to have IR.
Yeah, exactly. So all that to say, when you are dealing with, and again, everybody who's checking in on the live stream today, thank you so much. If you have any questions or comments about what we're talking about today, please put it in the chat. If you're catching us after we have recorded this and you're just coming in after the fact, leave your comments or questions down in the comment section below. We're happy to talk about that today, even if it has nothing to do with what exactly we're talking about today. Put your comments, put your questions in there, and we'll talk about it while we're
Or
here.
if you got a great story or a solution to a problem,
Yeah, definitely.
please share your solutions.
Yeah, because IR is definitely one of those ones that has odd things happen.
Yes, it does.
So, and we'll talk about that later. So, what I'd like to point out again, we'll go back here to the top-down view. So, when we're looking at the infrared light, what's interesting is that the beginning 300 megahertz for the IR remote, it actually starts over here in the radio wave section. And that's kind of interesting because you wouldn't really think that it would. Now, in most cases, most remotes are not going to be in the radio waves. They don't, the remotes themselves only use a small section of the IR remote section. And that depends on, of course, when the remote was developed, when it was made by the manufacturer. And because nowadays we're actually closer to the 400 gigahertz range than we are the 300.
There have been some quirks through the years. Pioneer Elite in the late 90s had a very odd frequency range.
Right.
It was 51 meg.
Yeah.
B&O had an odd frequency range.
Yep.
Sony had some two-way stuff that used multiple frequency ranges.
Yep. Today we see a lot in the 38 to 32 gigahertz range, but that's actually different than what the light is itself. So you have the
carriage?
light. Yeah, exactly. So we have the color of the light that's used, and that's that frequency range that we talked about here. But then we get into talking about the carrier. So this is actually the modulated frequency of the infrared signal coming from the remote or from whatever device you're trying to use to control something. And we'll talk about that next. So Brent, what I'd like you to talk about, if you don't mind, is the problems with IR remote systems and the wires that are used if they're not correctly ran, because they run too close to something else. And I'll let you kind of discuss that.
We discussed this briefly, and yeah, the cleaners are in my office.
That's okay.
We discussed this briefly last week. Large noise unshielded wires or 110 wires can absolutely affect what's happening in the 110, or excuse me, in the IR. Now, in the past, and again, I'm an old man, so I started doing IR back in the 80s. Typically, what we ran was a 3-conductor shielded.
That's when you had the Stegosaurus that ran the wires for you, right? Okay, I'm just making sure.
Well, I used a Meerkat.
Meerkat. Okay. All right.
The long-toothed squirrel thingy from Ice Age.
Oh, yeah. Oh, yeah. Yep.
Give him an acorn and he's ready to do anything.
Yeah. Yeah.
We would use a shielded 3-conductor loosely wound with a drain.
Right.
And this was typically 18 gauge, so you could go quite a distance with it. That level of wire no longer exists, and everybody's running category cable now. And category cable can offer a whole lot of flexibility for you because the windings, first off, are designed to reject the 60 cycle and 50 cycle hum. And you have enough copper there, and they typically will go even greater range. Unfortunately, what a lot of people will try to do is to cut an IR cable and just solder or beanie onto it. Now, this is what happens when somebody tries to cut a wire. This is 32 gauge wire. There's only 3 strands of copper in each of these conductors.
Yes.
Please do not cut this wire.
Yeah.
You're not going to have enough there to do anything with. And when you break it apart, there's no guarantee you're going to get the right colors back together because they're all black.
Right.
So don't do it. If you have to extend this, and it happens, don't panic. There's a couple of solutions. Number one, if it's outside of the wall, just use a stereo mini headphone extension cable.
Yeah.
Stereo mini male, stereo mini female. So you plug the extender into the female, plug the male into your connecting block. Because that's what it uses, is a stereo mini jack.
Yep.
You're ready to go. If you are going in wall, don't cut this. There's a couple of ways to do it. One is to use our extender, our passive audio balance.
Yep.
And I don't recall the part number off the top of my head.
I can find it real quick while you're talking.
But it allows you to extend it over Cat5 with the direct plug-in terminal. The other way is Leviton makes these great quick port inserts. I'm going to switch to an overhead real quick here.
Go for it.
These great quick port inserts that are 3-conductor for stereo and 2-conductor for mono. And it just takes bare wires in the back, whether it's Cat5 or an 18.2 or an 18.3. With these, you can extend the system without cutting, without compromising the wires. Please do not do that. You can extend IR receivers back, and you can extend IR emitters out if you use the 2-conductor. You can use the 3-conductor for a 2-conductor, but you can't use the 2-conductor for a 3-conductor. Voltage will kill you.
So the part that you were talking about is the CS C535. So that part, it's actually pretty simple, and I think I've got one right here. In fact, I use it for my computer audio.
Because it's the same as audio.
Yep. So all it is basically this, and we hit the top down.
Yes, I will.
So with this here, basically all it is a 3.5, and it's an RJ45 on the other side, and you can wire that up however you want to wire it. We recommend using 568B, but it does not matter because you're only doing the audio signal down this path, so you could do
or the IR, which is the same conductors.
However you want to do it, just make sure it's the same on both sides.
Now, this is male at both ends.
Correct.
So you will need a stereo barrel, female to female stereo barrel,
There you go.
to hold this and this together.
Yes.
Not a big deal, and this allows you to use category 5 cable.
If you have to cut the wires,
Don't.
try not to as much as possible. It's one of those pieces that, like Brent was saying, it's so small. You really only you wind up with like 5 strands of individual strands on the inside once you actually open it up, and it's not the best way to do it, and we run into problems when it's done that way. So we recommend not going that direction with it.
There is one other way to go, and these are readily available on the internet or eBay or Amazon. This is a Breakout screw terminal, 3-conductor to stereo mini, and this is available as both male and female.
Right. Okay, so now that we got that out of the way, let's talk about how the infrared light actually transmit the command, how it actually gets that command from the remote to the device.
And it's fun because when you first look at this, you're thinking HDMI.
Yeah.
but it ain't.
No, it's not. So it's actually
And there
kind
were
of
some interesting arguments on this because both of us assumed
Yeah.
we knew what was going on.
We actually had to do research this past week to find out the right way to actually talk about
and
how the infrared light works.
It was a whole lot of fun to learn.
It was. It really was. I learned quite a bit about it myself to actually give this presentation. So when we are talking about how the remote gets the signal from the remote to the TV, the truth is it's magic. See you guys. We'll see you next time. I'm kidding. So the reality is that the way that it gets it from the remote to the display is it's using, of course, a binary language. And it means it's just simply zeros and ones. It's using pulse code at that point. Now, what we thought was that it meant that you had a high when the light was on, that meant a 1. And when it was off, it was off. That meant a 0. That's not the case.
No, it's Morse code.
It's Morse code. It's more closer to Morse code. So, of course, with a Morse code signal, you have dots and dashes. So a dot would be a 0 and a dash would be a 1. So what happens at that point is when the light flashes, you have dots and you have dashes all the way through. Oh, we do have it. Wonderful. Thank you very much. Thank you, Jesse. So we actually do have that part. We have the mono piece and we have the 3 conductor piece as well. So it's the stereo and that. It's the CS key 35-2C and -3C. So definitely check that piece out.
And by the way, we also have the barrels if you need them.
Yes, we do. So definitely check those out. Talk to your sales rep. Talk to your distribution partners and find out about those pieces as well. Highly recommend going that way with it instead of cutting and splicing.
Yeah, you can go a lot further and it's a lot cleaner.
Exactly. So now, here's how this works. When you have an IR signal going from the remote to the television, we'll use that as the example. Very simply, you've got zeros and ones all the way through. Now, we'll talk about this dash here in a little bit, but again, this is what happens when you look at the signal. It has a starting signal. And this is where you're actually kicking things off from the remote. There's a little bit of a spike here, and then it goes to an off state, and that's kind of our start announcement. We're saying, hey, we're ready to start talking to you and sending a command to you. So then at that point, that kind of kicks things on. It's the knock at the door. Right?
5-volt trigger.
Exactly, a 5-volt trigger on an HDMI. From there, it begins to send its information. So this would be like our command structure. Whoops, C-O-M-A-N-D. This is our command. So with this command at this point, look, I'm starting to write like you do.
Poorly?
Yeah. So with this command, of course, this is the binary command that it sends out from there. Now, very simply, when it wants to send a 0, it's sending a short burst of information, of light at that point. Now, this is where that carrier frequency comes into play, because we know where the light spectrum is, and that we choose that light spectrum for a very specific reason. That's to make sure that we have the least amount of interference as possible. Again, we've dealt with IR for a long time now. We know that it gets affected by light sources, by the sun, by radio waves, by anything. So we found that if we keep it within a certain range, it's going to help to keep away from that as much as possible. So what we do then from there is we then will have the carrier wave. Now the carrier wave is set at a certain frequency again to make sure that the information going from the remote to the TV or to the device is kept separate from another command, maybe going to a different device. But it's also to make sure that we don't get information from, say, an LED light, which is also sending out IR information to the display or to the device or whatever it is, because those use a slightly different carrier frequency wave than what the IR remote is using. So it helps to also mitigate that. But there's still a little bit of crosstalk. There still can be some
harmonics.
Harmonics, thank you. Some harmonics that will have an effect on that. We're good today.
Now, what's really most interesting about this is, again, talking about HDMI, it's highs and lows. This is all about the off status. When you look at a stream, once the light has started, the actual command is sent in the non-light status.
So I've actually got this a little backwards.
Because the light triggers the next command. So it's the off status is the actual command. Whether it's short or long, it's the off status.
There we go.
So at the top, you're pretty much always looking the same, but the bottom is what varies. And that's the off portion.
Attention.
Oh, there's now every 15 minutes.
All employees are required.
That's interesting. Okay, so
That's new.
What we are working with right now, of course, is, like Brent was saying, we have the off state is really what's actually causing or sending the information, sending the signal. So the light coming on is really just the stop. It's like when you're doing the, going through that, sending the telegraph that way. When you get at the stop, say stop, that means we're stopping that piece of information, moving on to the next piece of information.
For your old school Vantage guys, it's the press release.
There you go. So when you are dealing with IR information, what you have, of course, is that it's coming up to a high point. Now, this high point is where the light on the remote is on. So at that point, the light's on, and it's on for a short period of time. Then it goes to the off state. Now, the off state, like Brent was saying, this is where things actually stop, or this is where the information is. So the short distance here of the light stopping is our 0. And then it goes back up, lights up again, and says this is our stopping point. It says, hey, we're going to move on to the next digit. Then it goes back down to an off point. Now, of course, we go from this all the way across, and we have a 1. From there, we go up to the top again, and then we go on all the way through. Now, this is our command point, our command structure that we're actually sending across. Now, of course, the length of this can be longer than this. I'm just doing a very short amount.
It varies depending on the manufacturer.
Exactly, and each manufacturer is going to do something slightly different in order to differentiate themselves from that.
RC5 is the standard, which is a Phillips-based, but it could vary dramatically off of that.
Right. So from here, then we have our device ID.
If it's available.
If it's available. So what we have here with the device is this is going to be nice because if you have a device, so let's say you were using Sony Blu-ray player, Sony AVR, and a Sony TV. So the command may be the same command for all 3 of those devices, but and it means something different for each one of them. So this may be the play command on the Blu-ray player, but this may also be the mute command for the AVR. But what's important to know is the device ID. So for instance, 0101 may be the device ID for the Blu-ray player. 0100 may be the AVR, and 0001 may be the TV. So that is how we differentiate from the different points of communication for infrared. That's really the basics of infrared. From there, the last little bit of course, is a stop command, and that's just the lights off at that point for a while.
Yes.
And then at that point, it just says, okay, I'm done listening, that's the end of it. Now, it does a little bit more than that, because when we are dealing with, say, a control system, universal URC and RTI, Control 4, Crestron, Savant, whoever you may be using, Harmony,
Logitech?
I know. Not for nothing, they have an amazing IR database. They really do. Anyways, moving on. So when you are using those devices, they usually have the ability to resend a command multiple times. And the reason for that is because IR has a way of making sure that it's being sent across like it's supposed to. So if you send this on command multiple times within a short period of time, it's only going to be that one command that's sent through it. The device doesn't normally receive it.
It will accept X amount of repeats.
Exactly. Now, some devices only accept a certain amount of repeats. Some devices accept a much greater amount of repeats. It just depends on that device. And that's why most of those automation systems give you that ability to differentiate.
And having this at the end is very important.
Right.
Because it has to know that that particular command is finished, and if it repeats it multiple times, it will know. Now, particularly if you've done any kind of programming and you're like channel 33 on a cable box or a satellite receiver 333,
right,
you have to get not just the duration, but the repeat times. Otherwise, you may wind up with too many threes.
Exactly. Yep, exactly.
We've all been down that road, and it's frustrating.
It is, and it's very important to take all of that into consideration when you are designing your system as well. So this is a bunch of information about how IR works. Now we need to talk about actually using this out in the field and what you should be looking at. This is our tech tip point, all right? We're ready to actually talk about the tech tip portion to it. The truth is that IR is a very stable communication standard. It's been used for so long that we have found a way to make sure that it works in most every scenario. The biggest thing to take away from this is IR placements, making sure the IR bug stays on the device itself. And my favorite way to do it is using hot glue.
Or the shields.
Or the shields, because the nice thing about these shields, of course, is that they have a much larger pad of double-sided tape on it, which means that it has a much greater chance of actually staying in place. This is my favorite way to do it. After that, it comes down to the hot glue. So then, of course, from there, you have options of using whether you want feedback or no feedback.
Yeah, absolutely. And some people like to see the flashing because they know they're doing something.
Right.
Others don't like to see the flashing. It depends on whether or not it's visible. Typically, if the device is in a visible location, generally they don't want the flashing. As soon as I say that, somebody say, well, I use it on all my devices.
So one of the things that we run into with the IR emitters is the placement. And that's honestly, when we get calls about infrared problems, because we of course have our IR extender kits, the primary problem that we run into is the placement of the IR emitter and where it should be at. Now, there's a couple different schools of thoughts with this and the best way to handle it. My way of doing it, for me, has worked pretty much flawlessly for myself. Now, it may be different for you out in the field if you run into a different device that I've never run into on my side, but it's definitely something to look at for yourself. But if you'll give me that, what we have, this is of course our emitter here. Now, inside of the emitter is just a very simple LED.
Just a diode.
Just a diode on the inside. And of course, it's got some, let's see if I can do that right. Maybe, something like that. And all that's happening, of course, is the electricity, the DC electricity is just jumping from one side to the other, and that's emitting the infrared light. So the size and the distance away from each other is what actually creates the correct frequency of light to be traveling through this. And then the carrier wave is the frequency that this is turned on and off. That's the difference between the light and the carrier frequency. So now, the placement of this, when you are dealing with a certain device and you're trying to make sure that you have the IR emitter in the best spot for it, what you can look for on the inside, you will usually find some kind of circle on certain devices where you can see it, or a square, where you can kind of see through the black plastic that's in the front. And on the inside, you'll see a device that actually winds up having 3 legs. And what you'll see there, and it may be kind of difficult to see when you are looking inside of this, but you'll usually see something that looks like that. The way that I handle it and making sure that I have the correct placement is I will take this IR emitter and I will stick it right on top. And the reason I do that is because the IR emitter, it's not coming out the front, it's not coming out the bottom, it's not coming out the back or the top or the sides, it's coming out of all of them. And so putting it right there on top is going to ensure that I have the most capability of sending it around. Now, I have run into problems with that solution.
You can overdrive.
I can overdrive it. And so what I will do from there is I will take it, no longer sticking it directly on top of the IR receiver of that device. I will move it off to the side just a little bit and still have a small portion of it resting over top of that opening.
The other option on that is very effective is a little bit of tissue paper behind it.
Yes.
Particularly if you use the covers.
Yes, because the covers will keep it in place.
Right, that cuts down on the transmission of the light.
Right.
Now the covers are also nice because it helps keep out the visible light, and as we discussed in the beginning of the show, swimming pools, windows, flat panels, projectors, all will overload that.
I was looking for, and I was trying to find it, but I don't have one here. Cable boxes are one of the things that we run into a lot when we are out in the field doing the integration process. And sometimes it's difficult to find where the IR light or the IR receiver is. So the easiest way that I have found to do this, most if not all cable boxes will have vents on either the top of the box or on the bottom of the box, or even on the side. And very simply, I will take my phone, I will turn on the flashlight, and I will take that light and I will actually move it across.
Little silver square?
Yep, and then from there I will be able to see the light shining through the black plastic on the front of it.
See,
and that will usually
use my flashlight in a different way.
Mm-hmm.
I take my camera, my phone, turn it on, and then at a 45-degree angle, go across the front, and you'll see that break.
Yeah.
If you try to go straight on,
yep,
the reflection will blind you for it.
Exactly.
But at a 45-degree angle,
it's reflecting off.
It's
anyways,
reflecting off at an angle. All you have to do is find that. Now, it is, and it will get you, typically, particularly in cable boxes, I will find a second smaller opening.
Yes.
That's rectangle.
Yes.
I have no idea what its purpose is.
Nope.
But it ain't the one.
No, it's not.
It will be a fairly large square, about a half-inch square.
Yeah.
The rectangle is 1/4 by 1/2 on the cable boxes.
Yep.
The other one that's really frustrating is Apple TVs, because it is hell. The only way I have found on an Apple TV is I pick the remote up, I take the emitter,
Yep,
and just wait till I see something happen.
Yep, exactly. And honestly, that may be the way that you have to do it. One of the ways, one of the biggest problems that we have with IR, of course, is that when we get tech support calls, usually it's one person that's on site, and when you're trying to do an IR system, the reason you're doing an extender is because you're controlling something that's all the way over in a different room, it may be over in a different building.
Area, yep.
So you may, in those cases, it's best to have an extra person with you so that you can test, or you could be in the other room, they can be pushing buttons on the remote so you can actually see what happens.
Or have a tablet and a phone of the same manufacturer.
Yes.
And sign into FaceTime or Skype or one
Yep.
of those.
Yep.
Now, some manufacturers make it easy for you. For example, the Sonys.
Yep.
The Sony IR receiver is right on the bottom. So you just stick the emitter dead center right on the bottom, and you're there.
Yep.
It is awesome.
On most TVs from Sony.
On most Sonys.
Yeah. Now, another little trick that we like to do, of course, is when we get a call about troubleshooting and someone says, hey, the IR system's not working. Well, there's a couple things that we can check to make sure, because in most cases they're using an IR emitter that's not actually flashing. It's not a feedback emitter, so it doesn't flash for our natural eyes to be able to see what's happening. What you can do, though, is you can take your cell phone, take the camera that's on your cell phone, and it will actually show you what's happening. And I might be able to recreate this with our cameras here. Let me go ahead and switch over here, and I will grab a remote, and let's see if that actually works. Maybe, maybe not. Maybe, maybe not. Let's see if we can do it on here. But this is a great trick to be able to actually see if the remote itself is working.
There's too much overhead light.
Yeah, no, not gonna do it. Try it next time.
You can see it on the phone, but you guys can't see it overhead.
Try it next time that
by
you're
the way,
on
it's
site.
not red. It comes up as a light blue typically, or
Light
white.
blue, kind of a purplish, color to it. But definitely try that out. Even right now, if you have a remote sitting next to you, grab your phone, put the camera on, and you can actually point the remote at your phone, and you can see the light emitting from that. But it's a great way to troubleshoot and find out, is the emitter actually doing something? So the first thing you should be doing, of course, when you're running into a problem, check the remote. Make sure the batteries are good, point it at your phone, make sure you actually see something coming out of the remote that you're trying to use. From there, same principle, have somebody in that room when they're trying to, with the remote, point it at the emitter and keep hitting a bunch of buttons, and then take your phone into the other room and point it at the emitter, and make sure that the emitter is actually producing some kind of light coming from it. Using your phone, you can see what's going on there with that.
Typically, unless you have cut a cable, it's going to work.
Yes.
Cutting cables is when you run into problems.
Right.
Now, when you look at your typical connecting block, from every major manufacturer out there will be a Phoenix plug typically on the side.
Right.
And this allows you to do remote IR receivers and just hardwire it directly into the Phoenix plug. Now, you will have power, ground, signal, and status.
Right.
The status, the last time to my knowledge that was used was in the early 2000s. It just hasn't been removed. So consider that a NA and not available.
Not available,
not applicable. Don't worry about it.
Now, in a lot of these IR blocks, they will actually have two different power inputs on them.
Yeah, they look like two power inputs.
They look like two powers, but they're not. So make sure that when you're using it, you are actually plugging it into the power input and not the status input. You don't have to worry about that on the IR kit CCUS because there is no status input on it.
And the Phoenix plug does have a different purpose.
Yes, it does. So on that kit, the purpose that we use it for in our case, of course, the primary reason that we have this is actually because of our HDM-AIO2. And the reason that we have this piece is because the Phoenix connector is no longer an input for your IR receiver. It's now a contact closure. So when you are looking at this now, you'll see that you have an NA, A close, B close, and common. And what that means is that then you could use this, like Brent was talking about earlier, as a contact closure. So this could be used with our AIO2, and that's one of the main reasons that we use it. That's actually the reason that this is a thing. Yes, you created it. That's the reason that this is actually a real thing. But it actually can be used in many different applications. So let's say you have an RTI remote or a URC remote or something that has a remote and no base station that doesn't have contact closure on it.
Or a EA1.
Or an EA1. EA1 for Control 4. Now, in those applications, you may not have a contact closure, but you may need to control something that has contact closure, whether it be a screen for a projector, whether it be a TV lift or something else like that that takes
blinds,
contact closure.
LED lights.
Exactly. Actually, yeah, the LED lights, which we're going to be doing a video on that, aren't we? Yeah, that'll be kind of neat. So you can use the contact closure on this to actually control that, and it's IR learning. So you can learn a code, any code you want to give it, especially if you're using something like URC or RTI.
Yeah, if
give it a random code.
For it, pick like a JVC VCR.
Yeah, it's some old VCR that's not used anymore.
There's no chance of that code popping up anywhere else in the system.
Yep.
And use that code to turn on and off. Now, again, because it's A close, B close, NONC.
Yeah.
A lot of guys are not car audio. NONC is quickly not being known in our industry.
Right.
So I just call it A closed, B closed. If A is open, B is closed. If B is open, A is closed.
Yes.
And some devices require both for up and down or on and off.
Now, one of the things that we should talk about also is getting the signal from that control system into an IR block like this.
Now, we have a cable that's very specifically for this purpose. So if you have a control system, Crestron, Control4, RTI, Savant, doesn't matter, it's going to have a mono mini output on your controller. Now, a mono mini is just going to, your standard pin, one black part, and that's it.
Right.
The input of an IR connecting block or an HD-based T extender is going to have a stereo mini. Now, the stereo mini will have two black parts on it.
Right.
And that's how you break it up. So we have a cable called the CS-IR CC that is a mono mini on one side and a stereo mini on the other, and it floats the voltage. This way you can take that IR output port of any control system or HD-based T extender and go into the input of any IR connecting block and not have to worry about shorting anything.
Exactly.
You can also come out of a stereo mini device and go into a mono mini device. So if you're going, let's say you're coming out of a control system into a extender. Stereo mini to mono mini, or excuse me, mono mini to stereo mini. And then coming out of the extender into a connecting block, it's mono mini to stereo mini.
I actually had this call earlier with a gentleman who had that same situation. He was going from an RTI system, no, pardon me, it was a URC. He was going from a URC system into an extender, an HDMI extender that had an IR passback, and he was then going into an IR block on the other side because he had an HDMI splitter going off from there and he wanted to control it. So that's exactly what he did. At first he had just a stereo to stereo.
And it shorts things out.
And it shorts things out, and you really don't want to do that. He had a mono to mono, and same thing, you're going to short things out. So instead, he put this in there, and everything worked fine because it's floating that 12-volt power. Now, this is actually more important than you think, because shorting that out, you're not just shorting out your control system, you're actually shorting out the block itself.
Possibly damaging one or the other or both.
And we've seen that a lot. When guys actually will take the IR receiver, this is another reason not to cut the IR receiver wire and splice it, but instead to use a breakdown
breakout
a breakout punch or a breakout device. And the reason for that is that you can very easily cross those wires and put them in the wrong inputs
you don't
by
want to
accident.
send 12 volts down a 5 volt feed.
Well, and it's not just a 5. Yeah, you're going to short out the IR receiver, you're going to short out the IR block, and you're just going to have problems. And so that's why we're big proponents for don't cut, instead use the devices that are available to you so that you don't have to worry about that. So. But yeah, as always, everybody, if you have any questions or any comments about anything that we're talking about, please go ahead and let us know what you have to say. In fact, let's see.
Now, while you're reading those, for IR components, we carry the IR Kit CCUS, which has 4 emitters and is a 6-port block, an IR receiver, and power supply. Now, these are non-flashing emitters that come in the kit. We do sell single and double flashing emitters.
Yes, we do.
We sell the additional stickies. We sell the covers. We also sell the connecting blocks, the emitters, and the IR receiver and power supply as single units. And we have the IR Kit CCUS as one kit that also comes with 4 emitters. There's 6 ports. So you can add more to it. Very flexible. I love this thing because of the ability to control lifts.
So Bill Lloyd is actually asking us an off-topic request. He says, if we get a chance in the live stream, can you give us a quick demo of the FM XL75 behind you?
Yes.
A pull TV to full extension, side to side, up and down. The real questions around here, these are the good ones. So yes, so this mount is actually my favorite mount that we have in our lineup. The FM XL75 is actually the largest mount that we have, and the extension capabilities of it, it's kind of hard for you to see on the camera because you're coming at it straight on. But just to give you an idea, we'll go ahead and pull this straight out.
Please note that on the Sony, we are grabbing top and bottom on this. The Sony is a very thin set, and particularly with OLEDs, you don't want to just grab the bottom because it will bite you in the hiney. What if I switch over to the side angle camera?
I don't think that's going to give enough of it. But what I will do, so what I've done now is I've actually taken this out, and this tabletop, I am from the TV being all the way back to being at the very front of this tabletop that we have here.
At center point, we are 31 inches out.
And that's not even all the way out.
I'm sorry, 32 inches.
Yeah. And so
and there's
then
still
from
another,
there,
I tell you what.
Yep, there you go. That should be 32 right there.
No, yeah, it's 32.
Yep. So the extension capabilities are great. Now you'll see it looks like it's off kilter. It's because of my installation. I did a bad job because I was in a rush when I did it. But the nice thing is that you can actually go like this, and you can center it out. Ta-da! But the cool thing about this, of course, let me make sure that my wires are okay to do it. I'm going to go this way with it. Now, because I'm extended out as far as I am with that, I have such a large range with that mount to come out from there to actually get back behind it and do work with it. Or
I'm going to push it
in some cases. Can you see it better there?
Almost, but not quite.
Yep. Now, I actually had a customer of mine that was, they had a mount on their back porch and it didn't do this. And so we replaced it with this. And the reason was...
There we go.
There you go. Yeah, that's better. The reason for that is when you, where they had everything laid out, their couch was actually up against the wall. The wall was going this way and they were looking down this way. So they wanted to pull the TV out and turn it towards them at almost a 90-degree angle. And so that was what this mount allowed them to do. And they left it there, and it was there for 3 years, I think,
now,
if not
Adam
longer.
and I use this mount a lot.
Yeah, not just for here, we use it in
on
installations.
all the jobs that we do, because it just makes servicing everything so much better.
Right. So we'll get this back into place.
Again, please, with modern televisions, use both hands.
Yeah, top and bottom whenever you're using
They're
those.
just so thin.
Yeah, they can definitely cause problems with that. So I'm going to switch us back over here to that camera. So yeah, no, great question. It's a great piece. It's one of my favorites. Definitely.
And it's in stock.
Yeah, and it is in stock. Yeah, so reach out to your rep or reach out to your distribution firm that you work with, and you can find out more information about that from them. But great piece. So thank you very much for that question. But we'll jump back over into IR real quick because I do want to talk about the importance of
USIR?
USIR versus 5-volt IR. So, well, and it's not so much US, it's Xantech versus others.
China.
So what you have, of course, when you are dealing with an IR system, and we're running out of time, so I'll touch on this really quickly. There's two different kinds. You have Xantech brand, which is or standardized,
which has
setup.
been the industry standard since the 70s.
Yes, and so that runs on a 12-volt powered system. Then you have a 5-volt system that is completely different. Now, it may use the same 3.5 millimeter plug as the 12-volt system. However,
that's the only similarity.
Yeah, if you try to intermingle those, the 5-volt system can have different pinouts than the 12-volt, so you can send 12-volt power down the wrong thing or 5-volt power down the wrong thing.
They also modulate differently and they encode decode differently.
Exactly, and so you need to make sure to understand which one is which. No problem, Bill. Happy to do it.
If you have to put the two together, we encourage you to use what we call an optically isolated connection.
Yes. What is
which
that?
is
so very simply, all you have to do is take the IR receiver for
we
one
have
of
one
them.
right here.
Do you have one out?
We're going to use that one.
Okay. Oh, do you have a?
And there's an emitter.
There you go.
So you take the 5-volt IR receiver.
Here, let me give you a top down.
From your Chinese product.
Yep.
And you stick the emitter on it.
Yep.
And you tape them together, and that's an optically isolated system, and there's no chance of it damaging.
No. Yeah.
Because there's no actual electrical connectivity.
It's not the prettiest. It's not one of the ones that you're going to want to set up and have it be out in the living room of your client's home.
But it works.
But it works. If you have to do something behind the TV or if you have to do something in a rack somewhere and you don't have the correct equipment to do it, it is something that can get you off the job and get things working the way that they should work.
Typically, when you're dealing with a Chinese IR that comes with an extender kit, something like that, the IR emitter is more of a blaster. It's not really an emitter. It's not designed to stick on the front of a piece of gear.
Right.
It's typically designed to sit on a shelf and blast
control
everything
in that space. Yeah. So that's another thing. Be mindful of what you are working with at that point. Now, some brands will use a 2.5 millimeter plug versus a 3.5, which is a nice way to know. Usually the 2.5 is going to be your 5-volt systems, and so don't even try to use the
unless
adapters
it's old
or anything
URC.
else.
Because old
That is
URC was 2.5.
Yes, it was. Yep. And Logitech uses 5 on their systems.
They are 5.
Yep, they are 5-volt. It's not a 12-volt system on theirs.
And one of them is it Savant that's 5?
No, Savant's. Yes, it is.
Yes,
and I got corrected on that.
Yes.
Our friends over in the UK at RGB Distribution, great team over there. If you guys watch this video, it's great to hear from you guys every once in a while. I was actually at a training with them, and I said that Savant and Control 4 and everybody else was 12 volt, and very quickly I was corrected. Savant is a 5 volt system. I did not know that until they told me about it. But you do now. But I do now. Yeah. So yes.
And for Savant, guys, if one of you could call and honestly spend a little time with Adam or I.
Yeah.
He's Control 4, I'm Crestron, I'm RTI. We both understand URC.
Yep.
Don't know enough about Savant to have honest opinions and knowledge.
Yep. So with that said, one more time, I'm going to put a call to action from everybody who checks out our videos. We are looking for information. We're going to be doing a video series here in the near future where we are going to be talking about tools and equipment that you should have as a new, fresh installer. We're also looking for tools and equipment and supplies
for your truck.
For your truck. These are things that you deem as necessity every time that truck leaves the shop. That need to be on the truck. And these are all tools that, as a new technician, you should have in your tool bag before you even do your first job.
And we have already gotten some replies.
We have,
some of the companies are pretty darn strict on their employees.
They are, and it's honestly, it's great, and I think it's a great thing to do, and we want to spread that information out as much as possible to everybody so that, listen, our industry, we need some work on some of our people out there doing installations, we need some help. And so we want to get this information out there as a fresh installer. And some of the ones that we've had feedback already, I stand corrected for myself, for my own toolkit. I was missing some of the things, then I would not have a job with that company, which is kind of enlightening for myself. So yes, again, we're calling call to action. Please send that information to my email address. It's adamr@metrohometheater.com. You can, of course, also email Brent at brentm@metrohometheater.com. Pardon me, I apologize for that.
That's okay. And don't forget, we're looking for 1,000 subscribers on YouTube, so call your friends, call your neighbors, call your kids.
Yeah. We like seeing those subscriptions with that. So
it lets us justify what we do to the powers that be.
Yeah, exactly. So with that, everybody, that's our discussion on infrared. If we missed anything, or if there's something that we need to know, or something we got wrong, or something we got right, let us know in the chat or in the comments below. As always, you can contact us. My name is Adam Rogers, of course, 386-492-8584. And of course, you can contact Brent.
866-839-9187.
Extension 2203.
2203. And that will find me regardless of where I am. Now, what is Friday, young man?
So Friday, our discussion on Friday, you put me on the spot for that one, pardon me, I'm trying to catch up. Friday we were talking about audio distribution.
You want sound where?
You want sound where? So the idea for Friday, we're going to be talking about getting speaker level audio to different areas and how to distribute it in the best way to go about doing
Maintaining impedance control, not killing your amplifier, and how far can you go?
Exactly.
And next Wednesday is?
Next Wednesday, we are talking about, man, you put me on the spot.
NVRs.
NVRs, yes we are. That's correct. And in fact,
is kind of scaring me, Adam.
I know, you're catching up better than I am. It is a little scary. Next Wednesday, we're going to be talking about NVRs and DVRs and the basics of them. And just the general concept of how to get those set up for that. So definitely check us out next Wednesday. I will say next Wednesday is going to be a pre-recorded episode. However, I will be in the chat during that episode, and I believe you will as well.
He will.
No, I will be.
Now,
so,
what is next Friday?
Nothing.
And why?
We are dropping Fridays.
It's also the 3rd. It's a day
also
off.
the 3rd.
However,
we will not be here Friday, but
Friday will become our new product intros and quickie Q&As, things like that.
Yes, so still check in on Fridays. Still give us we
got lots of new stuff happening.
Subscribe, hit that little bell so you'll know when all the new videos go up for that information. We're trying to get more videos out there and more information out to you technicians and dealers out in the field to help you out. So
tell us what you want.
Yeah. Let us know what you want. Let us know if we did something right with a like. If we did something wrong, let us know. Give us a call. Shoot us an email.
And particularly send money.
Oh, well, yeah, of course.
We're not proud.
With that, all that to say, label your wires. Reboot
early. Reboot often.
I missed one.
No, you didn't.
Yeah.
Label wires. Reboot early. Reboot often. That was it.
That was it. There we go. I'm Adam.
I'm Brent. Have a great day.
We'll see you next time.